Hi there! Welcome to Science Made Simple by Ms. Flumps. Our second 9 weeks coverage includes the unit on energy transfer and conservation. We have discussed already the forms of energy transformation, potential and kinetic energy, and now we'll be learning about electric circuits. For our standard 6P38.3, I can construct explanations for how energy is conserved as it is transferred and transformed in electrical circuits. Our cross-cutting concept, we have cause and effect, and stability and change. For lesson introduction, I have here a video link. It's a YouTube video entitled The Power of Circuit. So if you want to see it, you can just type this YouTube link in the YouTube so you'll be able to watch this Power of Circuit video. So electric circuits. Electricity is a flow of electrons around a circuit. So consider this red with letter E as the electrons. So this electricity is a flow of electrons around the circuit. So for example, in here, the entire thing here is a circuit, and that includes the battery. This might be the wire, and we have the lamp in here. Electric circuits allow electrons to flow from a negative pole, excess electrons, to a positive pole, deficient in electrons. So look at this. So that means if this is your battery, the electrons will leave the battery from its negative end and will be moving towards the positive end of your battery. So because your electrons is negatively charged, so they will go out from the side and they will be attracted towards the positive side of your battery. So this entire thing is what you call electric circuits. All circuits need 3 basic parts: an energy source, which is in this case the battery, the wires, and the object that is going to change the electrical energy into another form of energy, which is the load. For example, we have here the light as the object that is going to change our electrical energy. So electric circuits sometimes contains a switch that is used to open and close a circuit. So this is the switch in here. So this is what you call an open circuit because there is a gap in here. So in this case, if this is now our battery, so the electrons will leave from the negative side of the battery. It will not jump over to this other side here. So the flow of electrons will stop here. So if there will be no continuous flow of electrons going towards the bulb will not lit up. Like in this case, it's what you call a closed circuit. Why closed? Because there's no gap. So if the electrons from this battery or energy source leave this negative side, and it will flow towards the bulb and goes on here in a circular manner, the bulb will lit up or light up because this is what you call a closed circuit. So you will know if it is a closed circuit when the light bulb lit up. So here are other illustrations wherein this shows 4 ways in which a simple circuit can be made. It could be like this. So you can try this at home if you have a battery, a simple bulb, and a wire. Just be extra careful then. But you can try this at home so you can attach this three together, and you will notice that this bulb will light up. Same thing with this. It can be done this way, or this way, or this way. So still, this will form a closed circuit. There will be no gap, and the electrons can freely flow from the negative side to the positive side, and this will now make our bulb light up. So here in this case, energy is being converted to light energy, and because you have the bulb here. Or if you have other things in here, like a fan, for example, then your electrical energy is being converted to mechanical energy. If you have a buzzer in here, so your electrical energy is being converted to sound energy. But there are also other things that is being considered when you deal about electric circuit. We have an electrical conductor and we have an electrical insulator. When you say an electrical conductor, it is a material in which charges can move freely or electrons can flow freely. When you say an electrical insulator, is a material in which charges cannot move easily or their electrons cannot flow freely. So I'm going to talk more about this in demonstration later on. But remember, an open circuit can be used to test whether an object is a conductor or an insulator, which I'm going to do later on. So now I'm going to be showing you how to make a simple circuit. So here I have my battery. I have my bulb in here. I'm going to put it here. So I'm going to be making a closed circuit so that my bulb will light up. We're going to do it this way though. That way. Alright, so I'm connecting. So let's see. So you see that because there's no gap, and you look at the flow of electrons, it's going out from the negative charge of the battery to the light bulb and then returning back to the positive side of the battery. So I have here a closed circuit. There's no gap in between, so that makes now the light or this bulb light up. So in here, the electrons are freely flowing in this circuit. What if I'm gonna remove this? Observe what will happen to the light. So there's a gap in here. So this is an open circuit. So you notice when there's an open circuit, the light will not lit up. Alright? So that is what you mean by this is how the electricity flows in the circuit. If the circuit is open, so no electricity can flow freely around in a circular manner, so your bulb will not light up. So what if I'm gonna put something in here. So let's try now. We said earlier that an open circuit can test whether an object is a conductor or an insulator. So we said a conductor allows electricity or electrons to flow through and therefore will make this light or this bulb light up in here. Whereas an insulator will not allow electricity to pass through, so thereby this light will not light up in here. So let's try the dollar bill here and observe whether this light or bulb will light up. Alright, there you go. No sign of light in here. So this, click here. So that dollar bill is an insulator because it's not allowing the electrons to flow through it, and thereby our light bulb is not, or there's no light in our bulb. It's not lit. But let's try our paper clip. Okay, observe what will happen to our paper clip. Observe what will happen to our light bulb as I attach this paper clip. There you go. So that means our paper clip is a conductor because it allows electrons to pass through it and thereby making our bulb to light up. So that is what you mean by an insulator and a conductor. Let's remove this and try the coin. So can you guess, is the coin an insulator or a conductor? Let's observe. Alright, so our coin is a conductor because it allows electrons to pass through it and makes the bulb lit up. So this is a conductor. Let's try another one here. How about our eraser? Is our eraser a conductor or an insulator? Look, it's not. So there's no movement of electrons, so therefore our eraser is an insulator. So what can you infer now, or how will you know if the object is a conductor or an insulator? So usually the conductors are made up of metals. So metals are good conductors. They allow electricity or electrons to pass through it. Whereas the non-metals, like the eraser and the paper bill earlier, they are called insulators. Thereby, they are not allowing electricity to pass through them. So that's why if you notice, our cords or our wires, they are covered with rubber. And rubber is an insulator, so that will not be hurt when the electricity flows through the wires. So our wires are covered with rubbers, and rubbers are insulators. So it will keep us away from being harmed when we try to hold this, when we plug in our cords or our chargers. Alright, so I hope you learned something from this video today and you'll be able to apply this learning to your daily life. Thank you and have a great day.